Let's see. Okay. So for number 7, the recommended dose of Retrovir for adults with symptomatic HIV infection is 1 milligram a kilogram, infused over 1 hour. Determine the dosage for a client weighing 110 pounds. So really, we don't even need that 1 hour because it's not asking us, what's the infusion rate. Yep. Why isn't it not letting me add a text box? There we go. Okay, so 110 pounds divided by 2.2 for your conversion factor is going to give you 50 kilograms. And then this part's pretty easy, but like I said, I usually do all this in my head. So 50 kilograms times 1 milligram a kilogram is going to give you 50 milligrams. So that's your dose. Because it's 1-to-1. And so for this one, we're going to, let's see. So your order is 0.3 grams. Your tablets are 150 milligrams, so we've got to convert it. And like you said, we can either multiply by 1,000 or just move it over. Let me get my paper. So that's going to give us 300 milligrams once we convert. And then we're going to divide that 300 milligrams by our available dosage, which is 150 milligrams a tablet. And that's going to give us 2. So 2 tablets is your answer for that. All right. Oh, uh-oh. So for 9, our order is the 25 or 0.25 grams are available are equal to 1 gram. And then directions for reconstitution. So we've got our 1 gram vial. We're going to add 10 milliliters to provide 95 milligrams per milliliter. So that right there is really all the information out of that big old paragraph that we need. So again, you're going to convert it from the grams to milligrams. So 0.25 times 1,000 is going to give you 250 milligrams. And just like the others, we're going to divide it by the 95 milligrams per milliliter. And that's going to give us 2.6 milliliters. And so for part A, using the information provided, what concentration will the nurse prepare? Well, your available is the 1 gram, so you are going to prepare the 1 gram vial. To give you the 95 milligrams a milliliter. And then we've already done our math, so we are going to dose 2.6 milliliters for that one. And they want us to shade it in. So there you go. All right, and for number 10, our order is 3 milligrams and which of the tablets would be best to administer to the client. If we've got half a milligram tablets and 2 milligram tablets, we know we need 3 milligrams. Go ahead. Yep. Mm-hmm. Yep. So, um, yeah, 2 milligrams. Yeah, they like to throw so much more information in there to get you to think. And I mean, I understand that, but it's not going to be this hard in real life. Let's see, 1 milligram, and then yeah, yeah. And so that gives you a 3 milligram dose. Let me just highlight this real quick. All right. Okay. All right. And so for number 11, we want to transfuse 1 unit of packed red blood cells. So that's 250 milliliters over 3 hours. The administration set delivers 20 GTT a milliliter. At what rate in GTT a minute is the IV going to infuse? It's number 11. So we've got 250 milliliters in 3 hours, and we need it. It's going to go at 20 GTT per milliliter. So if we divide the 250 milliliters by 3 hours, that's going to give us our rate per hour, which is going to be 83.3 milliliters an hour. Nope, because we got to find the GTT a minute. Yeah, and so once we have the milliliters an hour, we know it's going to be 20 GTT a milliliter. So we're going to multiply that 83.3 that we have by 20 GTT a milliliter. And that's going to give us 1,666 GTTs an hour. So that means in 1 hour, you're going to have 1,666 drops. And I'm going to cross it out. I'll cross out my milliliters. That's how I know I'm getting the GTT an hour. And then again, we're going to divide that by 60 minutes so we can get our per minute. Let's see. Come on. Oops. That's what's wrong. Come on. Move my box. There we go. Well, it's not wanting to work with me today. There we go. All right. So once we divide that by 60, we're going to get 27.8 GTT a minute, which is, going to round to 28.8 because you can't have a half a drop. 28 GTT a minute. It's just a lot of, back and forth between your bases and then what you got to multiply it by and then divide it to get what they're asking for. Let's see, number 12. All right, so a client is receiving 500 milligrams of Flagyl IVPB Q8H. It's been placed in 100 milliliters D5W to infuse over 45 minutes. Administration set delivers the 10 GTT a milliliter. And so this is basically going to be like the other one. We've got 500 milligrams and 100 milliliters in 45 minutes at 10 GTT a milliliter. And let's see, the first thing, we need to know how many milliliters we're giving in 45 minutes. So the 100 milliliters divided by the 45 minutes is going to give us 2.22 milliliters a minute. And once we have our milliliters a minute, we are going to multiply that by the 10 GTTs per milliliters. And that's going to give us 22 GTT a minute. And we don't have to divide by 60 or anything because we're doing minutes, we're not doing hours. And so you can cross out the matching milliliters. That gives you the GTT a minute. All right. And calculate the infusion time for an IV of 1,000 milliliters of D5NA infusing at 60 milliliters an hour. And they want us to express the time in hours and minutes. So 1,000 milliliters, and then we're going to divide it by the 60 milliliters an hour that we were given. And that is going to give us, come on, 16.67 hours. And then to get the number of minutes, you can just multiply 60 minutes by 0.67 hours, or 0.67, yeah, 0.67 hours. And that's going to give us 40 minutes. So your answer is going to be 16 hours and 40 minutes. You good on that one? Okay. Okay. And then this is all the fun, way too much information. So the prescriber orders the Septra suspension, 60 milligrams, for a child weighing 12 kilograms. The pediatric medication reference states that the Septra suspension contains the trimethoprim, 40 milligrams, and sulfamethoxyl, 200 milligrams, and 5 milliliters oral suspension. So we'll highlight just what that dosage or availability is. And the safe dosage is based on the trimethoprim. So we don't need to know that. We just need to know that there's 40 milligrams in 5 milliliters. The safe dosage is 6 to 12 milligrams per kilogram per day of the TMP given 12 QH. We already know it's given 12 QH. So is the dosage safe? And this is where the fun part is. So we don't have to convert the weight because we know he's 12 kilograms. And our order is 60 milligrams. Our available, well, our safe dose is, no, excuse me, I'm sorry. Our available is going to be 40 milligrams in 5 milliliters. And our safe dose is 6 to 12 milligrams per kilograms per day. So, first thing we want to do is find out what our base is on the our available. So 40 milligrams divided by 5 milliliters. Now, is this the step that you were talking about earlier about the conversion factor, where you line them up? Uh-huh. Okay. I didn't know if we could apply it to this one to try it out. Okay. Well, if we take this, what number is this again? This is 14. So if we take this, let's see. Actually, we don't even need this. Ignore what I said. Maybe. Maybe. Hold on. Let's see. Orders. All right, hold on. I'm going to delete that for a second. So, 60 milligrams is our order. That's our available. Our safe dose is 6 to 12 milligrams per kilogram per day. Let's start on the low end of our safe dose. We're going to do 6 milligram per kilogram per day. And we're going to multiply it by the kilograms. Our child is 12 kilograms. So 6 times 12 is going to be 72. So that's our max dose in 24 hours. That is the minimum safe. And if we do 12 milligrams per kilograms per day and multiply it by our child's weight, which is 12 kilograms, that should be 144 milligrams. And so that's our safe dose range. It's going to be 72 to 144 milligrams per day for this child. And he's getting 60 milligrams every 12 hours. So 60 times 12 because or times 2 because there's only 24 hours in a day is going to be 120 milligrams a day for this child. Let me see. I kind of did completely backwards on my thing here, but this is a lot more simple. So, yes, ma'am. So it's safe. Let's see where we're at. Okay. And for 15, a medicated IV of 100 milliliters is to infuse at a rate of 50 milliliters an hour, and this one should be pretty simple. Got your 100 milliliters, and we're going to divide it by the 50 milliliters an hour they're asking for, and that's going to give us 2 hours. And then if it's saying we started at 10 a.m., and what time will it be completed? 10 to 11, 11 to 12. So you would be completed at 12 o'clock p.m. or in military time, it would just be 1200. All right, let's see. All right, so a client is to receive 10 micrograms a minute of nitroglycerin IV. Concentration of the solution is 50 milligrams and 250 milliliters. What should the flow rate be in milliliters an hour to deliver 10 micrograms a minute? So, if we know we already want 10 micrograms a minute, and we need to find out the milliliters an hour. So if we multiply 10 micrograms a minute by 60 minutes, that's going to give us 600 micrograms an hour. Let's see. And then we're going to go ahead and convert and put that over here. And we're going to convert our 50 milligrams in 250 milliliters, find out our base rate, which is going to give us 0.2 milligrams per milliliter. And then now we need to convert that into the micrograms, which 0.2 times 1,000. 0.2 times 1,000 is going to give you 200 micrograms a milliliter. So we need 600 micrograms an hour, and our dosage is 200 micrograms a milliliter. So we've got, we're gonna take our 200 micrograms a milliliter that we have available, and we're going to divide that by the 600 micrograms an hour that we're looking for, and that's going to give us 3 milliliters an hour. I think. Hold on. No, I did that totally backwards. Sorry. Yeah, that's where I messed up. So 200 milligrams a milliliter. Yeah, I did that completely backwards. Because that's our rate we need it at divided by what's our available. So Oh, this is not working for me. There we go. And so it's another fun one. Our order, let me get my next paper, 17. We need to know the total units that are going to be administered. We need 6 units of the regular and 16 units of the NPH. So literally you are just going to add 6 plus 16. And that's going to give you 22 units. And so that's your total number that you're going to administer. And then it's going to ask you to do the syringe, which I have tried to, when I do these problems, to do them in the correct pull, you know, just like if you were doing it in class, of how many, you know, which to pull first. So you would pull your regular first, obviously, and that's going to be up here. So for the first 16, because you're drawing it second, is going to be NPH. Let's see, 2, 4. So, oh, this is great. Okay. So that would all be NPH. And then for the other 6 to give us 22 is going to be the regular. It's totally horribly drawn, but yeah. And so for 18, your dosage of 500 milligrams in a volume of 3 milliliters is to be diluted to 55 milliliters. It's to infuse over 50 minutes. And it's not even going to ask us about this, so we don't need to know that. What is your dilution volume? So, your dilution volume, I think this is one that I kind of struggled with, honestly. So you want it to dilute to 55 milliliters total. So we're going to subtract the 3 milliliters, which is, you know, your original, and that's going to give you 52 milliliters. And this is what I struggled with, is it's asking for the dilution volume. It's not asking you, you know, what is the number. It's actually, you know, like if you were diluting it with saline. So how much of the saline are you going to put in? So that is that. And then at what rate in GTT a minute should the IV infuse? So if we've got 55 milliliters total, and we're going to multiply it by 60 GTT a minute, which again, I kind of teach myself backwards. So the micro drop is 1 GTT a second. So 60 drops in 1 minute, a drop a second. And so once we multiply that, that's going to give us 3,300 GTTs in an hour, basically. Or just 3,300 GTTs total for that milliliters. And then we're going to divide that by 50 minutes because we're not doing a full hour infusion. We're only doing 50 minutes. So that's going to give us 66 GTT a minute. If your standard is 1 drop a minute, basically, here. Or 1 drop a second, I'm sorry. If your basic's 1 drop a second, and you're going to do it less than 1 full hour, you're going to have more drops per second. It's not going to be even. So that's going to be your answer. It's kind of confusing. Yeah, I don't even remember having any kind of problems like this on tests or homework. But you know, it's all multiplying and dividing. And then for C, indicate the rate in milliliters an hour. This one just, goes back to your basic dividing. If you've got 55 milliliters and you want to give it in 50 minutes, since we don't have a full hour yet, our rate per minute is going to be 1.1 milliliters per minute. And then we're going to multiply that by 60. To give us our actual rate per hour. And that's going to give us 66 milliliters an hour. It's just confusing because it's not full hours. And that's where it gets tricky. You just have to remember that you just can't, do it by the hours. You have to go by minutes and then figure it out from there. Oop. Um, that's what this is. Yeah. I just figured like this would be the best way to do it. Yeah. Yeah, so that was the plan. Just if I could get these done and I could explain how to do them. Yeah. So for this one, have y'all done these yet? Oh, the one she didn't lecture on? Okay. All right. So if she hasn't lectured on it, there's 2 formulas. One is for the, I think one's household and one's metric is what they call them. So for your metric BSA, let's see if I can do this. Your metric BSA is going to be your kilograms times your centimeters divided by 3,600. Let me move this over. And then that's all going to be in, oh yeah, uh-huh. So I can't, yeah. So that's the metric. And then but there is also one for the household. So you don't have to convert if you have to do inches or, pounds, and so that would be inches times pounds. The only thing that is awful is that it is 1313 is what you're actually dividing it by instead of the 3600. If I'm correct, I wrote that down. Yeah. Okay. Do you have a graphing calculator to put these into? Okay. All right. So I'm gonna work this out on my calculator as I do it because there's specific buttons you can push to make it easier. Um, if we do the 102 pounds multiplied by the 51 inches, and then we'll divide that by the 1313, and then let me put my horrible square root. And so once we work that out, that's our answer. So for the calculator, you're gonna first multiply the 102 by the 51. Oop. And that's going to give us 5202. And then you can just hit the divide by 1313. And that's going to give us that big, huge, long number. And instead of trying, huh? Well, that's the thing. I didn't round. So 3.96111, 2. Yeah. So instead of trying to round, I just do, so you hit the second button, and then you hit the X2 button, and then you're going to hit the second button, and then the button next to the enter, which has the parentheses with the negative in it. And that should put it should say answer. Okay. And that way you don't have to try to round or anything. Yep. And then that goes to the question where it says calculate. Yep. Wait a minute. Hold on. Sorry. 1.31. Let me see, because I wrote something down different, but I mean, we just obviously did it correct. So, it's 19. Huh. 102 times 51 is 52. Oh, you want to hear something funny? I got my numbers backwards. It's 3131. Yeah. Are y'all going to be able to use no, like a note card? Well, I just know Miss Halter said we were going to be allowed to use 1 3x5 to do our test with for formulas and stuff. And I planned on just doing my just like these formulas, because obviously you switch those numbers you get a completely different answer. So for 5202 divided by 3131, second, so that's actually going to give us 1.6, and then that's going to give us 1.288972465, which is 1 point, where'd my paper go? 1.29. And then that's meters squared, but I can't do the squared on here. I'm pretty sure that's double, triple check it again. Yeah, 1.29 meters squared. Yeah, that's why I'm going to have to write down my, my formulas, because otherwise that would be my luck to do it backwards just like that and just screw myself up. There we go. Yep. Yep. The 3,600 is for, actually, 3,600. Yeah, 3,600 is for kilograms and centimeters, which for whatever reason, I think 360 degrees in a circle and circle centimeters. And the household is the 3131. Yep. Yeah, I should have looked at my formulas before I started talking. So 20 for the acyclovir IV is going to be administered to a child. The child weighs 13.6 kilograms, is 60 centimeters tall, and the recommended dosage is 500 milligrams per meter squared. So they want us to do the same thing just like the last one. So 13.6, and we're going to multiply it by 60 centimeters. No, I'll zoom out a little bit so you can see all that. Oop, way too far out. Yeah, it took me a good while to type all this. That's part of the reason it took forever to be able to do this. And so we're going to multiply that and divide it by the 3,600. So 13.6 times 60 is going to give us the 816, and divide that by 3,600. It's going to give us 0.2266666667, and square root answer. And I got 0.476, so that's going to round to 0.48. And so that's going to give you, so that's going to give you your meter squared that it's asking for. On the first part of the problem, And then the second part, it's asking what will the dosage be. So the dosage is calling for 500 milligrams per the meter squared. So you're just going to multiply 500 milligrams by 0.48, which is going to give you 240 milligrams. And since you know 0.48 is like almost half, you're doing almost half of what your available dosage or the recommended dosage per a full meter squared. And let's see. And then I honestly, going back and looking at the answers, checking it as I'm working them out, there's no reason it's showing this available here, because it's not asking, you know, what, you know, milliliters an hour or however, except for C, and then it's giving you its own thing there. So that's just a whole bunch of information, again, that you don't need. So for C, it's saying 50 milligrams per milliliter is what it's the reconstituted Zoviraز is. And then how many milliliters do you administer? If you need 240 milligrams for a dosage, we're going to divide it by the 50 milligrams a milliliter. And so that is going to give us 4.8 milliliters. How you doing on that one? Yes. And we can do that in the way you were talking about earlier. Because that's the one I did. So if we have 50 milligrams, hold on, 240. If we have 50 milligrams in 1 milliliter, we know that. And we want to find out, I'm actually going to put it backwards since that's kind of how we did the other one to make it a little more simple. And we need 240 milligrams. And how many milliliters do we need to get that 40 milligrams? Yep. So, yep. I mean, it would, yeah, it would be different if it was like 5 or 6 or something. So, yeah. Yeah, it's just, you just got to make sure you're putting everything into the right order, and that's what I figured out. Okay, so prepare the following strength solutions: 2/5 strength Ensure plus 250 milliliters. So we need 2/5 strength, and we have 250 milliliters. Where am I at? I'm on 21. I need my next paper. 21. So we're going to do it the same way. We can do it either way. We'll do it this way first to figure out 2/5 equals basically I'm just about to find out what percentage of 100 is 2/5, which basic math I'm terrible at for some reason. So for what percentage, we'll basically do it the same way as the other one. 5 times what equals 100. So 5 times 20 equals 100. So 2 times 20 is going to equal 40. So we need to know 200, no, I'm not even doing that. 250 milliliters times 0.40, which is, the amount of how much percentage you need, and that's going to be 100 milliliters. So you would put 100 milliliters of the Ensure. And I would assume another way you could do it is 250 milliliters divided by 5 parts. Let's see. It's going to give 50. Milliliter a part, and then you would just multiply 2 parts. Yeah, I mean, like if you needed it, I guess like, let's see, if you needed it, let's say 3/10 strength, and 250 milliliters divided by 10 parts, so that would give you 25 milliliters per part. Yeah. It's just think of like you have 4 quarters and $1. They all equal 25 each, but they all 4 together make 100 cents. Yeah. So we have a child weighing 21.4 kilograms, has an order of 500 milligrams and 100 milliliters. The normal daily dosage range is 40 to 50 milligrams a kilogram. and that's a daily dosage, so you know that's 24 hours. Is it within normal limits? And state the course of action. So, let's see. And it's being given every 12 hours. That's the other thing. So, it'll be 2 times this amount a day. So first we can figure out what amount that child is going to be getting a day. So 500 milligrams, which really we don't need to know the milliliters because it doesn't matter. It's not asking a rate. Times 2 doses per day. It's going to give you 1,000 milligrams. Thousand milligrams a day, or 24 hours. And then we're going to find out our dosage range. So if we do 40 milligrams times the 21.4 kilograms, which is what the child weighs. Let's see what number I'm on, 22. 40 times 21.4 is going to give us 856 milligrams per day. And that's for the low side. And then we'll do the high side, which is going to be 50 milligrams times the 21.4 kilograms. And that's going to give us 1,070 milligrams a day. Our normal dosage range. Normal dosage range is going to be 856 milligrams to 1,070 milligrams per day. And the order is going to be 1,000 milligrams in 24 hours. It's a yes, ma'am, so it falls in the safe range. So it's safe and you can administer the dose. I'm going to do one more problem and then probably stop for a little while. I got to cook some dinner. Okay. Oh, no, you're fine. Okay, so calculate the amount of dextrose and NaCl in 2 liters of D5 quarter NS. So first things first, you know, you've got 1,000 milliliters per liter. So one, one. All right, got that. And then, so this is a standard, and again, one of those backwards learning things. I learned how to do it after I learned how to do the problem. If it's saying regular NS, that's going to be 0.9 in 1,000 milliliters percent. And then half NS is going to be 0.45, and a quarter strength NS is going to be 0.225. So to figure out our dextrose, and dextrose is another one of those constants. Let's see. you're going to have, for regular dextrose, you're going to have 5 grams in 100 milliliters, or 1,000 milliliters. No? In 100 milliliters, excuse me. Yeah. So we're going to kind of do that, the fraction kind of type again. So if we know we have 5 grams in 100 milliliters, X grams in 2,000 milliliters. So 2,000, you can divide it by 100, and that's going to give you 20. So we know 100 milliliters times 20 equals 1,000 milliliters. So 5 grams times 20 is going to give us 100 grams. Of dextrose. And we're going to do the same thing with the NaCl. So we know for a quarter strength, which is it's calling for, it's going to be 0.225 grams in 100 milliliters. I'll put that up here too. And then that'll equal to X grams over the 2,000 milliliters. And we'll do it the same way. If we already know out of 100 milliliters, it's 20. You're just going to multiply the 0.225 times 20. Same way. It's constant. And then that is going to give you, should give you 4.5 grams.